Welcome to Bedtime Science. Last night, while you were sleeping, Mount Everest grew a little taller, just a fraction of a millimeter, but it grew. The tallest mountain on Earth was once an ocean floor. Tonight, fossils of small sea creatures still rest near its summit. That single observation holds the story of 500 million years. In the next moments, we will move slowly through 100 quiet facts about Mount Everest. We will look at the ancient sea that became the Himalayas, the thin air above the highest clouds, the Sherpa villages and monasteries below the peaks, the slow rise of the mountain that continues even now. If these quiet hours offer comfort, consider subscribing to join our community. Leave a soft comment naming a place on Earth we should visit next. Now let's begin. The peak we call Everest stands at 8,848.86 meters above sea level. That figure was confirmed in 2020 by a joint survey carried out by China and Nepal. An earlier measurement, recorded in 1955, gave 8,848 meters. Both were correct within the limits of their instruments. The mountain itself simply kept rising in the years between. In 2024, a study in Nature Geoscience added a quieter observation. Everest is being pushed upward by close to 2 millimeters each year. The cause is a slow geological process called isostatic rebound. When rock and soil wash away from a region, the weight on the crust below begins to lessen. With less weight pressing down, the crust floats upward, much like a ship lightened of its cargo. About 75 kilometers east of the summit, the Arun River carves a deep gorge through the Himalayas. As the river removes rock, the land around it rises in response. Over the past 89,000 years, this lifting has added between 15 and 50 meters to Everest's height. The story of how this peak came to exist began far earlier, in a warm and shallow sea. Around 180 million years ago, the land that would one day become India was joined to a vast southern continent called Gondwana. Between India and Eurasia stretched a tropical ocean named the Tethys Sea. It was warm and shallow, dotted with reefs full of marine life. The Indian plate then began drifting northward. The cause was the slow churning of currents deep within the mantle. For tens of millions of years, India moved at about 9 meters every century, slow beyond measure and impossible to stop. 40 to 50 million years ago, India met Eurasia. Both plates carried thick continental crust. Neither could sink beneath the other. The only relief was upward. The collision has never finished. India continues to press northward and the mountains continue to rise. In geological time, the crash is still happening. The rocks at the very top of Everest are about 450 million years old. They are pale limestone formed on the floor of the Tethys Sea. Geologists call this layer the Kamalangma Formation. It is the highest stone on Earth, and it once lay underwater. Just below the summit lies a band of golden limestone called the Yellow Band. It dates from the Ordovician, an even older period in the planet's history. Inside it, scientists have found fossils of trilobites, crinoids, brachiopods, and small drifting ostracods. These were creatures of shallow tropical waters, now resting nearly 9 kilometers above any sea. In the time it took a single grain of that ancient seafloor to be pressed into rock, lifted by tectonic forces, and carried to the top of the world, more than 400 million years passed. The Indian plate is still moving. Its pressure does not only build the Himalayas, It is also slowly pushing parts of Asia eastward toward the Pacific. The Himalayas now hold the third largest store of glacier ice on Earth, after Antarctica and the Arctic. For this reason, they are sometimes called the third pole. Glaciers carve the flanks of the range, while isostatic rebound pushes the peaks higher. The mountains are shaped by two opposing forces, working across timescales the mind can barely hold. The next group of observations turns from the rock below to the air above. At the summit of Everest, atmospheric pressure drops to about 314 hectopascals. That is roughly 31% of the pressure at sea level. Each breath there carries less than a third of the oxygen available at the ground. The percentage of oxygen in the air does not actually change with altitude. It stays close to 20.9%. What changes is the density of the air itself. Fewer molecules in each lungful means less oxygen reaching the blood. At sea level, the partial pressure of oxygen is about 21.2 kilopascals. At the summit, it falls to 6.6. That drop crosses the threshold of what the human body can sustain without slow deterioration. At Everest Base Camp, near 5,364 meters, oxygen availability is about 53% of sea level. At Camp 4, on the South Col at 8,300 meters, it falls to roughly 33%. At the summit, only 31. Above 8,000 meters lies the region climbers call the death zone. The body there consumes oxygen faster than it can replace it. Even fully acclimatized climbers cannot survive long at that altitude. Blood oxygen saturation often falls to between 55 and 65%. At sea level, those readings would call for emergency care. Water itself behaves differently in such thin air. With pressure dropped to about a third of a bar, water boils at roughly 70 degrees Celsius. That is not hot enough to cook pasta and not hot enough to brew proper tea. A pot left on a stove at the summit would simmer for hours without ever getting hotter. The bubbles arrive too soon, and the heat escapes before food can soften. That same low pressure can leave climbers feeling subtly altered in ways hard to describe. Pens often leak more easily. Sealed food bags expand and sometimes burst inside packs. Air escaping from a cracked bottle leaves with a soft hiss as the trapped molecules rush into the thinner surroundings. The thin air also changes how light scatters above the highest clouds. At extreme altitude, the sky shifts from familiar blue toward a deep indigo. With less atmosphere overhead, the colors begin to approach the darkness of space. High above the peak, a fast band of wind called the jet stream often passes directly over the summit. Speeds typically run between 130 and 225 kilometers per hour. At their peak, they can climb beyond 400. When the jet stream sits low over Everest, climbing is impossible. The narrow window for safe ascent usually arrives in May. That is when the jet stream lifts northward, just before the summer monsoon arrives. Temperatures at the summit never rise above freezing. In July, the warmest month, the average is around minus 19 degrees Celsius. In January, it falls to about minus 36. Winter wind chill can drive the felt temperature down to minus 60. The cold at the summit is not the same as the cold of a polar plain. It is drier. The air carries almost no water vapor. Skin loses heat through radiation as much as through convection. Even breathing pulls heat away with every exhalation, because the lungs must warm and humidify each thin lungful before it can be absorbed. Sound itself behaves differently in such thin, cold air. The speed of sound drops as temperature falls. With fewer molecules to carry vibrations, sound dissipates more quickly. The silence above the clouds is not only psychological, it has a physics. Within the Himalayas, more than 95,000 glaciers spread across roughly 15 subregions. They are the source of 9 of Asia's great river systems. Hundreds of millions of people drink from water that began as snowfall on these peaks. Those glaciers are melting now at about 10 times their average rate over the past 4 to 7 centuries. Since the end of the Little Ice Age, the Himalayas have already lost about 40% of their glacier area. The meltwater has raised global sea levels by between 0.92 and 1.38 millimeters, a quiet planetary echo of the mountain's thaw. On a clear night, the stars above the summit shine with a depth unfamiliar to the lowlands. Without lower atmosphere haze, the Milky Way appears more luminous and more three-dimensional than almost anywhere else on Earth. The peak has been home to people long before any of these measurements existed. The Sherpa people are a Tibetan ethnic group living in the high valleys of eastern Nepal. Their two main regions are the Khumbu and the Salu, near Everest. Oral history traces the Sherpas back to Kham in eastern Tibet. Their ancestors crossed the high Nangpa La Pass into Nepal around the year 1533. In Tibetan, the word Sherpa simply means people from the east. The name is both a cultural identity and a geographic memory. These communities settled on sun-facing hillside benches in the upper Khumbu. They built terraced fields and yak pastures at altitudes that would leave most lowland people gasping. The yak, known scientifically as Bos grunniens, is the cornerstone animal of high Himalayan life. Yaks carry goods, give milk, and provide wool and fuel across passes above 4,000 meters. Their hearts and lungs are noticeably larger than those of lowland cattle. Their pulmonary arteries have thinner walls, which lets blood flow more easily. Their red blood cell counts are higher too. The yak genome shows signs of adaptation to thin air. Several genes in the HIF1 alpha pathway, including ADAM17 and ARG2, help cells respond to low oxygen. Another, called MMP3, plays a related role. In summer, yak herds graze on the high alpine pastures above the villages. In winter, they descend to lower paddocks below the snowline. Their hair is long and shaggy, with a soft undercoat that traps warmth. The animals can survive temperatures that would kill ordinary cattle within hours. For centuries, yak caravans carried salt from Tibet southward through the Himalayas, returning with grain from lowland Nepal. These trade routes crossed the same passes the Sherpa ancestors once used. The Sherpa people follow the Nyingma school of Tibetan Buddhism. It is the oldest of the four main Tibetan Buddhist traditions, founded by Padmasambhava, also known as Guru Rinpoche, in the 8th century. Nyingma teachings draw deeply on local spiritual presences along with the formal Buddhist divinities. Alongside the Buddha and the recognized Buddhas, Sherpas honor gods and protective spirits that inhabit specific peaks, caves, and forests. Tengbach Monastery, also called Dawa Churling Gampa, sits on a ridge above the meeting of trails leading toward Everest and Ama Dablam. It was founded in 1916 and is the spiritual center of the Khumbu. Each autumn, the monastery hosts the Mani Rimdu festival, with masked dances and blessings that draw pilgrims from across the region. Older still is Pangbach Gampa, founded in 1667. It is among the oldest monasteries in the Khumbu. Sherpa life often involves several languages. Sherpa is spoken at home and in rituals. Nepali is used for trade and administration. Tibetan is read during religious study. English is common in tourism contexts, a multilingualism born of altitude, trade, and history. Over generations of living at altitude, the Sherpa people built a deep practical knowledge of mountain weather, snow conditions, and safe passage through crevassed glaciers. This kind of knowledge cannot be gathered in a single climbing season. It comes through inherited experience across centuries. Sagarmatha National Park, which contains most of the Khumbu, was established in 1976. It is now a UNESCO World Heritage Site. After the rise of mountaineering and trekking tourism in the 1950s, new schools and hospitals were built throughout the region. Above the villages, snow leopards move silently across the rocky slopes. They prefer altitudes above 3,000 meters. Higher still, bar-headed geese cross the Himalayas during migration, beating their wings at altitudes above 7,000 meters. Juniper trees grow as high as 5,000 meters, while lichens colonize bare rock close to the snowline. Some of the rivers that fall from these slopes carry water that arrived as snow thousands of years ago. The peak has carried many names long before any map in a distant capital tried to fix its height. In Tibetan, the mountain is called Chamalungma, often translated as Goddess Mother of the World. The name is reverent, and it speaks of a relationship to the peak that is spiritual rather than competitive. In Nepali, the same mountain is named Sagarmatha, from Sanskrit roots meaning forehead of the sky. Together, the two names frame the peak not as a thing to be conquered, but as a divine presence to be honored. According to Tibetan Buddhist tradition, a goddess named Myalangsangma resides at the summit of Chamalungma. She is one of the 5 long-life sisters, and her virtue is described in 2 words: inexhaustible giving. She is held to be a beneficent presence, offering gifts to those who approach with respect. The colored prayer flags that flutter from passes and ridges are older than Buddhism itself. Their roots lie in the Burn religion of ancient Tibet, where colored cloths were used in rituals honoring mountain gods and nature spirits. These flags appear in 5 colors, always in the same order: blue, white, red, green, and yellow. Each color carries an element. Blue is the sky and space, holding boundless wisdom. White is the air and wind, carrying prayers outward. Red is fire and life force. Green is water and harmony. Yellow is earth and stability. The flags are inscribed with the mantra Om Mani Padme Hum, the mantra of compassion, alongside images of the lungta, or wind horse. The horse is said to carry prayers into the open sky on each breath of wind. Importantly, Tibetans do not believe the prayers are addressed to gods. Instead, the mantras printed on the cloth are dispersed by the wind into the surrounding world, a continuous, wordless gift of goodwill sent outward from the mountain passes. For the Sherpa people, the peaks are not inanimate. They are inhabited by protective deities. Each clan traditionally worships particular summits. To enter the high mountain without first conducting a puja, a ceremony of offerings and prayers, would be to proceed without respect. Long before any Western map gave the peak a number, ancient routes already crossed the Himalayan passes. The Nangpa La Pass, at 5,716 meters, has linked the Khumbu Valley to Tibet for at least 500 years. It is a corridor of snow and prayer flags worn smooth by yak hooves. The first Western attempt to measure the highest peaks of the Himalayas began in southern India. The Great Trigonometrical Survey of India started on April 10, 1802. On that day, a British officer named William Lambton measured a baseline near Madras. 2 decades later, in 1823, an engineer named George Everest took over the survey. Under his direction, it expanded northward across the Indian subcontinent. By the time the work was complete, the survey had covered around 56,997 square miles of triangulated measurements. In 1852, an Indian mathematician named Radhanath Sikdar, working for the survey under the official title of chief computer, made a careful calculation. Combining observations taken from 6 separate stations, he determined that a distant white shape on the horizon, then known only as Peak XV, was the highest point on Earth. For Sikdar, the work of the chief computer was painstaking and slow. He used logarithm tables, careful trigonometric reductions, and many cross-checks before he was willing to publish. Light bending through the atmosphere, the curvature of the Earth, and small errors in instrument leveling all had to be accounted for. Sikdar's calculation gave the height as exactly 29,000 feet, or roughly 8,839 meters. His supervisor, Andrew Waugh, worried that such a round number would seem like an estimate. He added 2 feet and announced the official height as 29,002 feet in 1856. In 1865, the Royal Geographical Society named the peak Mount Everest after George Everest. Everest himself reportedly never saw the mountain, and he had preferred that it be called by its local name. For most of human history before then, the peak existed mostly as a distant white horizon. It was seen from trade routes and monastery windows, unnamed in Western cartography, but deeply known by those who lived in its shadow. The Survey of India was later described as one of the most stupendous works in the whole history of science, a monument to patience, precision, and the slow accumulation of knowledge across generations. The first widely accepted modern height of the mountain, 8,848 meters, came from an Indian survey in 1955. In 2020, a joint China and Nepal survey produced the figure used today, 8,848.86 meters. They used GPS, gravimetric data, satellite imagery, and modern computing methods that Radhanath Sikdar could never have imagined. Yet his trigonometric method was accurate to within meters of theirs. For most of the history of life on Earth, the rocks that now form the summit of Everest were ocean floor. Only in the last small chapter of the planet's story have they become a peak in the sky. The next set of observations turns inward, to what happens inside a body trying to rest at the edge of the sky. At altitudes above about 1,800 meters, sleeping patterns begin to change in nearly everyone. The most common change is called Cheyne-Stokes breathing, or high-altitude periodic breathing. The pattern is unmistakable. Several deep, rapid breaths are followed by a moment of stillness, sometimes a brief pause where breathing stops altogether. Then it begins again. The cause is a disturbance in the body's normal feedback loop of ventilation control. In thin air, the brain receives mixed signals from oxygen sensors and from carbon dioxide sensors. The result is cycles of breath and stillness, like the mountain itself breathing through the sleeper. Even elite athletes experience shorter, more fragmented sleep at altitude. The body's ability to rest deeply is one of the first capacities to falter. Above the high camps, mild hypoxia combines with isolation and sensory reduction. Climbers often describe altered perception of time, weakened short-term memory, and a feeling of expanded stillness. The present moment becomes very large. Many climbers report vivid dreams during their nights in the upper camps. Some are bright almost to the point of being lucid. Others are fragmented and strange. The thin air seems to soften the boundary between waking and rest. Some climbers in the high camps of Everest have reported what scientists call the third man phenomenon. It is a sensed presence, felt rather than seen, perceived as a quiet companion. This kind of somesthetic hallucination has been documented in scientific literature. It arises from a mix of hypoxia, exhaustion, isolation, and sensory deprivation. In one of the larger studies on altitude sickness, hallucinations were present in about 3% of subjects. The brain uses about a fifth of the body's oxygen even at rest. It is the first organ to register thinning air. In the death zone, it enters a state of critical hypoxia. Some cognitive abilities are affected more than others. Long-term memory and psychomotor function tend to suffer first. Problem-solving and inhibitory control are more resistant. Appetite, by contrast, fades almost entirely. The digestive system slows, and meals become difficult to finish. Climbers can lose several kilograms of body mass during a single summit attempt. In the high tents, the wind never quite stops. It flaps the fabric with a steady, high flutter, often carrying flecks of ice. Inside, the temperature can fall to around -30 degrees Celsius. Beyond the thin walls, the darkness is complete. In conditions of such cold and dryness, the bodies of those who never return remain preserved. Few microorganisms can break down tissue at that altitude. The mountain, in a way, keeps what it holds. The bodies of the Sherpa people have, over many generations, become quietly adapted to this thin air. A gene known as EPAS1, sometimes called the superathlete gene, appears in about 87% of Tibetans and Sherpas. In Han Chinese, the frequency is closer to 9%. The two populations separated less than 3,000 years ago. The contrast is one of the strongest signals of natural selection ever recorded in a human population. Research published in 2014 in Nature and Nature Communications established something further. The Tibetan version of EPAS1 is nearly identical to a variant carried by the Denisovans. The Denisovans were a group of archaic humans who lived in Asia, perhaps 30 to 40,000 years ago. At some point in the deep past, ancestors of the Tibetan and Sherpa peoples interbred with Denisovans. They inherited this unusual form of EPAS1. In lowland populations, the gene lingered at very low frequency. At high altitude, those who carried it thrived. Most other high-altitude peoples, such as Andean highlanders, respond to thin air by producing more hemoglobin. Their blood thickens to carry more oxygen, but their hearts must work harder to push it through. The Sherpas do the opposite. Their blood holds less hemoglobin, flowing more easily, placing less strain on the heart. At the cellular level, the Sherpa body simply uses oxygen more efficiently. Professor Andrew Murray, a physiologist at Cambridge University, put it this way: It's not how much oxygen you've got, it's what you do with it that counts. In studies at 5,050 meters in Nepal, researchers measured the diffusing capacity of Sherpa lungs. They found that oxygen transfers from air into the blood at a substantially higher rate. The lungs are quietly more effective in thin air. Beyond EPAS1, several other genes show signs of adaptation, including EGLN1, HYOU1, HMBS, EP300, and NOS2. Together, they form a cascade of small molecular adjustments across oxygen handling, metabolism, cardiovascular function, and cellular stress response. The earliest of these adaptations may have arisen about 30,000 years ago, when later migrants from lower altitudes arrived on the Tibetan Plateau. They acquired some of these alleles through interbreeding, and natural selection rapidly amplified them. What makes the Sherpa adaptation remarkable is not just its strength, it is also its quietness. There is no visible marker, no obvious physical difference. Two people standing side by side at sea level, one Tibetan and one Han Chinese, might look identical and feel identical. But take them both to 4,000 meters, and within hours their bodies begin to tell different stories. What scientists have learned from Sherpa physiology now reaches beyond mountaineering. Researchers believe the same insights could help treat patients in intensive care whose tissues are deprived of oxygen. The mountain's secrets quietly entering the hospital ward. The human body, given enough generations, can adapt to almost anything. Even a world holding only a third of the oxygen the species first knew. The Sherpas did not conquer the thin air. They became part of it. The next section turns from the body back to the world around the mountain. In the villages below the peaks, evenings move slowly. Yak bells echo from the lower trails. Smoke drifts from kitchen fires. Inside the Gampas, butter lamps glow steadily through the cold hours. Each clan, each village holds its own protective summits. Before any climb, a puja is performed. Offerings of barley and butter are placed on a stone altar, alongside juniper smoke. Mantras are read aloud. The mountain is asked with quiet respect for safe passage. The 5 colors of the prayer flags continue moving in the wind: sky, air, fire, water, earth. Each strip of cloth releases its mantra outward, one breath at a time. Higher up, where no flags fly, the silence deepens. There are no bird songs in the death zone. No insects move through the rock. Only wind, snow, and the slow shifting of light across stone and ice. Lower down, in the rocky country between the villages and the snowline, snow leopards move alone. They are rarely seen. Their fur blends with stone and shadow. They are sometimes called the mountain ghosts of the Himalayas. Higher still, the bar-headed goose flies. Some pass over the peaks themselves during migration, beating their wings in air so thin no other bird could stay aloft. They have a special form of hemoglobin that binds oxygen more readily than ours. They cross the highest mountains on Earth and continue south, season after season, without pause. Below the high camps in the meadows above the villages, herders move with their yak in summer. The world here is shaped at human pace. Stone walls, slate roofs, mountains on every side. The night settles. In the high camps, the wind continues. In the villages, the butter lamps slowly burn down. Somewhere on the southern flank, a tent flutters. Somewhere on the northern side, a single fox crosses the snow and is gone. Tonight, while we listen here, the Indian plate is still pressing northward. Its movement is slow beyond all human pace, about as fast as a fingernail grows. Yet that motion has already pushed an ocean's floor into the sky. The marine limestone at the summit of Everest is older than the dinosaurs. It is older than the first forests, and older than any creature with a backbone. It was laid down when the largest living things on Earth were small, soft creatures drifting in warm water. Somewhere within that pale stone, the body of a trilobite still rests, its shell turned to mineral, its outline preserved. A creature that lived in shallow tropical light, now beneath the cold Himalayan sky. In the time it takes a single climber to walk from base camp to the summit, the mountain itself grows by an invisible fraction, less than a hair's width, but it grows. It is hard for the mind to hold these timescales at once. A single human breath, a glacier's slow grind across one rock, the patient drift of one continent into another. Each takes place inside the same world, and yet they belong to almost different physics. Long after our cities are gone, the Himalayas will continue rising and eroding beneath the stars. Their peaks will shift. Their ice will return and retreat. New rivers will cut new gorges through old stone. The mountain we call Everest tonight is a passing form. It is one shape in a long sequence of shapes. The continents will continue their slow movement on a scale of time that has no comfortable resemblance to a human life. And still the small fossils remain, quiet witnesses lifted higher than any sea has ever reached. The ancient sea, slowly lifted. The fossils of small creatures that once drifted in warm water, now resting beneath the cold stars. The thin air, the long silence. The prayer flags turning in the wind, releasing their quiet blessings into the open sky. The villages below the clouds, the fire inside the Gampa, the yak bells fading along the valley. The Sherpas in their houses, breathing easily in air that would leave any visitor gasping. Their bodies quietly adapted, generation after generation, to a world the rest of us could only ever visit. The peak above the clouds, the summit limestone once a seabed. The mountain continuing to rise, slowly, invisibly, about 2 millimeters each year. Tonight, above the clouds, Mount Everest continues standing in silence beneath the cold Himalayan sky. While you rest here, the peak rises a little more, just a fraction of a millimeter, but it grows. Sweet dreams, and we'll see you next time on Bedtime Science.